Hi students, this video is on ions. This is a display called the Northern Lights. People will see them up in the northern latitudes. It's supposed to be very beautiful. One of my goals is to go up and see it. Really what it is though is ionized gas in the atmosphere. And when ionization occurs, you get often very, very beautiful displays. And there's a lot more science behind it, but the formation of ions is what drives this display. So we're going to learn today what an ion actually is and then how to calculate ionic charges. So the first thing is that we need to be able to identify an ion. An ion is basically an atom that still has an overall charge on it, a net charge. The word net basically just means that if you take the positives and you subtract the negatives, you're going to be left over with some value. It's kind of taken from finance, where you have the gross amount that you end up taking, making in your paycheck, and then you subtract the taxes, and those are the negatives, and then you're left over with the net. This is your take-home pay, the net. So when we say the word net, we think about atoms, we think about positive charges, these protons, negative charges, the electrons, and the net is whatever's left over. Oops. So if an atom has a charge on it, that means that those two things didn't perfectly balance, which we would normally expect when we're, from what we've talked about in class so far. So if they do perfectly balance, like they do over in this situation, there's 6 positive charges, 6 protons, and 6 electrons, and they perfectly balance and they cancel out. Each positive charge canceling a negative charge. In this case, there's only 5 protons, a different element, and 6 electrons. This one has picked up an extra electron, and that extra electron means that the atom will have an overall or net negative charge. We'd call this a negative ion. This is a neutral atom, not an ion. And this is a negative ion. Well, can you have a positive ion? Yes, you can. You can have extra protons and not enough electrons to balance that charge out. So that extra proton is going to make the atom positively charged, and we call this a positive ion. So I wanted to add this slide in just a day after I recorded the original video, hence the costume change. But I wanted to show you some actual examples of ion symbols. So in this case, we have oxygen over here, and its ion, which always forms this 2- ion. This one's nitrogen, and it always forms a 3-. They actually wrote this backwards. They're supposed to write it that way. But this one also has the mass number and the atomic number. That doesn't always happen when people write notation. It's not required that you always put the mass number in the atomic number unless it's necessary for the kind of information you're explaining. This one is lithium. And lithium is important because of lithium-ion batteries. This is a lithium ion. In fact, lithium-ion batteries work because you basically are moving the lithium element. It becomes an ion, and you move it across a sort of like a fluid inside of a lithium-ion battery, and as it moves, it basically generates electricity. And the electron that leaves the lithium atom and makes the lithium an ion is the thing that actually causes the current to run in the battery, just in case you're interested. So lithium ion works because you basically lose an electron, and in the process of losing that electron, that runs a battery, like a phone, a computer. The very thing you're watching this on right now, in all likelihood, is being run on that process. So thank you, ions. And the last one here, this one's beryllium. And beryllium has a 2+ charge, which means it's lost 2 electrons. And of course, we've also got the mass number and the atomic number. So I just wanted to give you some examples of real ions, real symbols here. So when you see these ion charges or these symbols, you'll go, oh, that's an ion, because I can recognize what an ion looks like. The difference between an atom and an ion, as you may have picked up, is that atoms are always neutral. So their positive charges and their negative charges always add up to a net of 0. And that means that they never carry a charge. So when you see an atom written out, something like nitrogen, if it's atomic nitrogen, it would only be, it would just be written like this. But if it has a charge on it, like this, then you know that it is actually an ion of nitrogen. Ions are never neutral, and they always have a charge. So you've got some examples here of some charged particles there, along with the uncharged versions over here. So how do ions actually get formed? Well, the first thing to know is that it comes from the loss or gain of electrons, never the gain of protons itself. The protons never are added or taken away to form an ion. That's by definition changing the atom. So I'm going to demonstrate this by showing you what this looks like through the FET. So in the FET we had this little net charge thing over here in the corner, the little gauge that goes up and down in red and blue. The red being like the positive charge, the blue being the negative charge coming from the electrons. So if I take away an electron, if I take one away, I am left over with a little bit more positive charge. And this element of lithium is going to be overall, if you balance it out, more positively charged than it is negatively electrically charged. So in this case, we would create a positive ion. In the case of oxygen, and this is really what happens for oxygen and for lithium, it picks up electrons. And in this case, it actually picked up 2 electrons, and that's pulled it over quite a bit more on the negative side. So it's now a negative ion because it gained electrons, and that's because the positive protons and the negative electrons do not balance in their total number. So to go back to the naming of that, if you lose an electron, we have a name for that. It's called a cation. So the loss of an electron is a cation, and if an atom has lost electrons, it becomes a cation. If an atom gains electrons, it becomes an anion. So one way that I like to remember these two terms is that a cation is like a cat, and a cation has paws, or a cat has paws, and so cations are always positive. Anions, the word anion reminds me of the word onion, and onions always make me cry when I cut them, so that makes me sad. So negative charge on an anion. That one's not quite as clever, but at least you can remember one and it'll help you remember the other. So cation versus anion. And don't say cation, cation, like you're saying the word cat, ion. Okay, so a cation is when you lose an electron, just to give some definition here, and an anion is when you gain an electron. And this is the tricky part, though, for students. Losing an electron actually makes you more positive. And that's confusing because most of the time when we lose something, that's a bad thing and we think negative. But we're not talking about good or bad. In fact, it doesn't care really what happens to it. It's what happens to the overall charge. So if I have my positive charges and I have my negative charges, if one of those negative charges leaves, well, then I'm left with overall a positive charge. So losing an electron leaves me with a positive charge. An anion, gaining an electron, I become more negative, because if I had 3 and I gain an electron, if it comes in, I gain an electron, then I have become more negative because the electron carries that negative charge. Okay? I like this little meme over here. I think I've lost an electron. In fact, I'm positive. I've lost it. I'm positive. So just as many mnemonics as you can to reminding yourself what happens. And the more mnemonics you see, the more often people make them because they can't, it's hard to remember. So even writing some of the mnemonics down, those tricks for your brain are helpful. Okay, so let's do some practice problems here. This problem says a neutral nitrogen atom gains 3 electrons. And what charge does it have now? So if it's gained 3 electrons, each of those carry 1 negative charge. So nitrogen, which its symbol is N, if you take your periodic table out that you've hopefully been able to print and have handy. The neutral nitrogen atom gains 3, so we'll put N and a negative 3 minus like that. That's the way that we do notation, is that we put the charge up there kind of as a superscript or like a small number up in the top right corner. So nitrogen 3 minus. Also, be sure that you do put the 3 minus in that order. Don't go like this. Okay? Negative 3 is not the way, it's not convention how chemists like to write it. So you'll even see some chemistry teachers write it that way. That's incorrect. It should be written in that order, 3 minus. Make your college chemistry teacher happy and learn to write it the correct way, 3 minus. Bonus question, what kind of ion is it? Is it a cation or is it an anion? It is an anion. It's an anion because it's negative, right? And those onions that always make me cry, right? So it's negative. Negative. It's gained electrons, so it's negative. Okay, next problem. How many electrons are in this ion? That's tricky. All I can see is that it's got a positive charge. Well, I have to use my periodic table now because I have to know how many electrons the atom should have when it's normally balanced. Remember, normally the protons balance the electrons. So I have sodium right over here. Sodium's charge is, sodium's atomic number is 11. So sodium having 11 protons, then it's going to have 11 electrons when it's neutral. But it's not neutral, it has an extra positive charge. So that means that if I had all my, 11 protons stacked up, 7, 8, 9, 10, 11, and I had all my negative charges stacked up, I get 1 positive left over. One of those electrons left. And now I only have, well, the math is easy, isn't it? 11 minus 1, I lost 1 electron, equals 10. 10 electrons. How many electrons does it have? It has 10. 1 less than it would when it is neutral. How many protons? Well, I had to figure that out, didn't I, in order to answer the question. Bonus question, though, is this a cation or an anion? It is a cation because it's positive. Okay? So I hope that's helpful to understand the difference between ions and atoms, and that you can now tell the difference between an anion and a cation and calculate how many electrons something is going to have based on where it is in the periodic table.